Oh yes, that's good. I was getting very afraid now. Yes. Yeah, okay. Here you can see a picture of our hospital in Tønsberg in Norway. It's a hospital nice situated on a hill close to the city center. The hospital has 340 beds and a budget of about 2 billion Norwegian crowns. Vestfold Hospital Trust has a facility development program. It consists of 7 stages, where 6 stages have been completed. We started building in 1990. Stage 7 includes replacement of 2 ward buildings, the oldest from 1938. Decision made in 1995 to tear down the 2 ward buildings and stop further maintenance. It was not possible to establish modern and effective wards in the buildings due to the building geometry. Large investments have to be made in order to keep the buildings acceptable for hospital purpose. Here you can see the 2 buildings, which is our greatest concern at the moment. Building A was built in 1972 and Building B in 1938. Building A was built as a temporary building intended to last for about 10 years. Very poor quality. Before. Yeah, the status today. The facility development program has stopped due to lack of investment fund, and as a result, time is running out for all buildings. Large repairs have to be made in order to keep the buildings floating. Reduced capacity for more years. And real danger of collapse in the technical systems in the 2 old buildings. We owners' choices. We can rehabilitate the old buildings, cost about 50% of a new building. Reduce the capacity for months, years during rehabilitation, and still not functional and effective ward design. Or we can choose new building with modern and effective wards. But our challenges, we have to have short building period to avoid further investment in the 2 old buildings. And we, of course, we want low price, but not compromising the quality. As time goes on, the old buildings need more and more maintenance, which we want to avoid. Go on. Next. Har du ikke fått med det siste? Okay. Oh, that's nice. That's all right. Yes. You can go back to the picture. Development of the hospital site has gone on for a long time, but the board of Vestfold Hospital Trust decided in June this year to divide the 7th stage, building stage, in 2 parts, where the first part shall cover the capacity of the A and B building. It's about 200 beds in that 2 buildings, and the board, I want a solution in October this year, and I want the new building to be finished in 2013. This is a big challenge for us in my organization. It's exceptional short time to get up with a new project. We haven't got the time to involve the hospital staff in the work, and we must rely on the work done earlier in development of stage 7, and an experienced project organization and an experienced architect. We lost our last buildings, but that's all right. I guess Henrik will tell us how we are going to solve the problem and what we are going to present for our boards in October. Thank you.
Okay, then we are going to have a presentation by the architect Henrik Vestergaard, and he's going to do this in Danish, and I'm going to do a simultaneous translation into English. Yeah, but this is for the internet. This is for the other one. So. Okay, Henrik, then I think we are getting close. So then you just advance by pushing the left button. Yeah. So he would like to thank for being invited to have a presentation here. He's coming from an architectural company called C.F. Möller. And he's also been working on the project A House. That was one of the first building smart projects in Norway. So he has basically been following the development for the last years. And his perception is that there's a lot of dynamics in the process. And the usage of BIM is here to stay, and we see an increased usage of BIM in basically all our projects. The challenge with the Tønsberg project is that we have got an assignment to develop a ward unit in a very short time period. So as you can see from the screen, we're going to move some of the old buildings functionality over into a new area. The site is quite complex because it's an existing running hospital and it's operational. The challenge with refurbishing the old buildings is basically that they're too integrated into the old building, so that means we need to shut down a lot of the existing functions. If you could develop a new building, it would be much easier to construct. So what we've been doing with the client is doing a lot of sketching and discussing about how we could approach this. This is in principle a site plan. The area we're talking about is the which I indicate on the slide. It should be 240 ward or patient rooms, but it's a limit to the height of the building. At the same time, they need to have a helipad on the building. So it's quite a complex situation. A lot of surrounding buildings. And there's some loading bays and some important logistics parts for the rest of the hospital that should be operational during the construction phase. So the way we've been working is that we have tried to make this building that is defined by some standard elements. Because if we can utilize standard elements, we can decrease the cost of the project, which is important for the client. So we want to achieve a high degree of standardization. At the same time we're doing these sketches, we also make a 3D model IFC-based model of the same concept. And we sent that to Lars and Kimon so that they could use it as part of the Build Hospital Live event. So we had 3 wings, the A, B, and C wings, 1, 2, or 3, and they're sort of interchangeable, so providing a high degree of flexibility. And in some it's 250 beds. From the start, we wanted it to be cheap, to be standardized. And the standard are the toilets and the bathroom. And we've been inspired by the prefabricated bathrooms that are used in hotels. So we have some sort of parts of the building where we put these prefabricated bathrooms into the building, creating zones. And these are examples of how they're produced, prefabricated. We can utilize market competition to get down the price, and we can also lift them into the core, which means that we can do the project in a shorter time duration. Because both cost and time are key parameters for our client. And we also have a challenge because it's a very small construction site, so we don't have the capacity to store too much. Here we have made some sketches to illustrate the technical principles in this building. Because the technical system is actually a key part of solving the design challenge. We have the bathroom cores, and we have some shafts where we take all the technical systems. We have a technical subfloor, and we also have a technical floor at the top of the building. And we have the shafts, the technical shafts are indicated as I point. So this is the basic principle we try to deploy, and as you can see, we are trying to drive towards a very high level of standardization. When we create standard elements, it's of course important that they just become rigid, because we want to achieve a degree of flexibility. So the way we do that is that we have a standard wing, which has a 1 patient and a triple patient room. So the bathroom or toilet cores are not touched, but the other parts are actually quite flexible. And of course we have a different kind of isolation, both airborne and directly transferable, so that complicates. This patient triple room can be refurbished or changed into another function because it's close to the shaft. We have also some pre-rooms, so that there were anti-rooms, which makes us able to create isolation posts for patients too, or patient isolation rooms. Later in the project development, we need to establish some concepts for the facade system in the building. And here we have tried to work with some prefabricated elements too. This is something called Paroc panels, which is a load-bearing core. And when you have put that in place, you actually have a load-bearing wall structure, which you can then affix the rest of the facade to. And here's a picture about how it's actually assembled at site. And to close off the presentation, this is an example about how the final facade will look. So the existing building is brick, and we try to link to that with a new facade material. And we use some plaquette tiles on this system wall, which is shielding the facade and ventilating part of it. And this is sort of the final view of the building with the facade in place. And in the further development of the project, we need to work more with the colors in the facade. To what I now explained, we think that we have a good angle of attack, which will reduce the cost and also the construction time for our client. And we have, by bringing the project forward in regard to modeling, we also had the basis for doing a quick cost estimate on the project, which may be important. Okay, this was basically a short presentation about the Tønsberg project. And here you can see the Revit model, which we have used to also visualize. And during the process, we'll connect more and more systems to this model. But we need to make you aware that this is extremely early stage. So we won't go into too much detail. Okay, thank you much. Processes to be aware of, so I need to be here and there. Can you hear me? Okay. So now you got some insight about the project, and I must say thank you very much to both Arnor and Ellen, and also to Henrik for providing us with this material for the Build Hospital Live event. Okay, there is Build Hospital Live. That should be the last one. Yeah. Okay, now I'm going to give a quick introduction to the Build Hospital Live concept, and then Kimono Numa is going to bring forward some status report from what all the different teams in this competence and training event, Build Hospital Live 2009. The idea is basically a digital classroom for the AC industry. And it's about building smart-based project execution, past, present, and future. Build Hospital Live has a website, a EU and global website at www.bhl09.com, and also a US website. And we try to mirror the material, so in principle it should be the same you experience if you go either way. The backdrop for the competition is basic, or for the event, is basically the rising cost of healthcare, which is a major challenge for many countries. Also, the insight that the operational efficiency of a hospital is very closely connected to the built environment. And also, as actually was noted by our keynote speaker, we're talking about carbon pricing healthcare services. So the urgent need for a more environment-friendly built environment is also clear. The interesting thing also, as we showed this morning, is that the Nordic hospital market is substantial. We were talking about maybe 120 billion kroner. And if we could save maybe 1, 2, 3, 4, 5%, we're talking about billions, which is really important to try to attack. So the focus is better and faster hospital design, focusing on environmentally friendly hospitals, and also, as was mentioned from the architect, more health for less money. Building smart actually promotes new ways of collaborating and sharing information. And we can get new and more integrated work processes, and we can radically change or revolutionize the way we design and plan hospitals. I think Rolf mentioned that 7 man-months into minutes. I can't even calculate the factor, but it's huge. Few of the current hospital projects utilize Building Smart, even if you have been acquainted with some of them today. But what is definitely clear is that there is a competence gap. It's a competence gap both to how should these new processes of collaboration be executed under new contractual regimes, but also in reality, how do we use this kind of technological opportunities provided by Building Smart? As we have seen, some hospital projects have started, so new decision processes based on efficient information logistics are a reality as of today. And as we have seen, results are promising. So what is Build Hospital Live? It's a competence building and training arena. It's a learning and training event where individuals can improve their skills by training and participating themselves, or they can gain insight observing processes and products of the teams participating. So what what started out as a competition has changed into no competition. First of all, it's the fact that the Norwegian architects and engineers working in hospitals are too busy. So basically the feedback was, we don't have time to participate. And the other comment was basically that if we have too much to do, why should we use our spare time to compete about something we can't win? The other one is also that Building Smart is basically about collaboration and sharing. And as we mentioned earlier today, the key values of Building Smart is sharing and collaborating towards a win-win situation. However, as I mentioned during the speak from Statsbygg, we are trying now to get a project, a real competition, where you can compete for real results in Washington, D.C. in December during the AC EcoBuild Sustainable Construction Conference. The status as of today, or actually it was yesterday, was 80 people have participated from more than 25 countries. The global digital classroom is actually become a reality because of Byggreisdag. And Byggreisdag is a Norwegian or a Scandinavian building product fair, and they have seen that they need to go from atoms into more of bits and bytes. They think that knowledge and efficient exchange of product information is definitely the future. So their contribution to creating this arena at Byggreisdag is actually that they want to help the industry become educated to take advantage of the new opportunities. As we mentioned, this is a global event, so here is Norway, for those of you that are following us in the cloud. This is Washington, D.C., and actually what we have started now in Oslo will continue all the way to December in Washington. In 2005 in Norway, we had a big Seeing is Believing, where we presented a lot of tools that were actually interoperating. So technically, it was possible to do these things in 2005. I think we now have started to get more exposure and more experience, and I think we also focus much more on the process issues and not so much on the technology. So the technology is starting to get down. In order to work well, we need a good process focus, and in this list from the American Institute of Architecture California chapter, it says that open-based technology is key to enable these new ways of collaborating. And what we try to do with the Open BIM is actually to this curve of freedom of choice longer in the project so that we can actually explore more opportunities without committing cost. This is basically what we want to achieve, and we will, in the presentation of Kimono Numa, we'll get some examples about how we can actually do things at a very, very low cost, early stage, where it may matter. And the key thing is that we're not taking away the traditional document production, but we're adding another element in early stage where people are working with a specific BIMs, and they're using open BIM to enable collaboration. And just to remind you about the website, and the idea that we have done is that we have tried to simplify project execution into 3 distinct steps. The first one is focusing on space planning. And as we had heard earlier today, there's also a functional planning based on demographic data in an area. The second stage is concept resolution, where we then involve the structural guys, the electrical MEP, and so on, to develop the concepts based on the needs to be fulfilled by the functional specification given in a space layout. Level 3 is actually to highlight that these models can be developed to a very high level of granularity. This is more sort of a demonstration step, because we wanted to show people that you actually can work from a high level of abstraction to an intermediate to a very detailed level, even in an early stage, because this is the cost carriers, and if you're going to make a cost estimate, it's important to have those also in the equation. Okay, then I'll close up for Kimon to get on stage. This is a simplified sketch of the process, meaning that in the early stage you have to work with the client in a very fluid and flexible way, also as the architect from CF Möller showed. Then the process stabilized a little bit, and then when we have decided on most of the conceptual issues, it's more a question about production. So what you will see now in the space planning part is actually part of the chaotic process, part of the process becoming more stable, and also we'll give some examples of concept resolution. We had a demo, actually 2 demos yesterday, and one of the key misinterpretations was actually that what we show you now is a compression lab. It doesn't mean that you should go back home and organize your project in this way. What you will see on stage today is basically something that would take maybe 1, 2, 3, 4, 5, 6 weeks in a normal project. So be aware. So some of the things you see today, we don't say to you that you should go about doing it, but we try to compress both the space planning and the conceptual resolution stage. So Kimon, are you ready? And of course, while Kimon is coming up, I would thank all of our sponsors from Möller to Helse Sør-Øst, Software Innovation, and so on.
Thanks, Lars. So while we're setting up here, I think one important point is to highlight again that the building that you saw earlier in Tonsberg, they were generous enough to share the plan files with us to be used as part of this Build Hospital Live. The plans were fairly developed, as you can see, and it actually helped us to be able to assign tasks. Yes, tasks to. Oh, we got a lot of people here. Let me see if I can grab. Okay, I'm gonna switch screens here for people live online. Okay. So the plans that you saw that Lars actually mentioned as well. So while we're setting up here, I think one important point is to highlight again that the building that you saw earlier in Tonsberg, they were generous enough to share the plan files with us to be used as part of this Build Hospital Live. The plans were fairly developed, as you can see, and it actually helped us to be able to assign tasks. Yes, tasks to. Oh, we got a lot of people here. Let me see if I can grab. Okay, I'm gonna switch screens here for people live online. Okay. So the plans that you saw that Lars actually mentioned as well. It's important to note that those were completed plans. We received some information. We didn't receive a lot of background information we had to kind of guess at. But the fact that we actually had plans to start with means that we could start assigning teams to either start from the very beginning. Imagine that the plans don't exist and you're going to start the design from the very beginning, or if you'd like to jump ahead and do a more detailed analysis on a completed plan. So it gave a wide range of places for participants to jump in. It was absolutely not required to do everything, like Lars said. You could do 1, 2, and 3, or you could just decide to focus on a very specific piece. Another part of this, the goals were to actually foster collaboration. We wanted to encourage teams to work with each other, regardless of their previous relationships. We wanted to show, and these are some of the teams that participated, we wanted to emphasize that it's possible to jump and collaborate with other teams, that you saw their work coming forward. So this transparency factor, that it was on the internet and it was accessible to the teams. For example, an architectural team could be doing the design and a structural team could be viewing the design and saying, here's one solution, and maybe another structural team would jump in as well. And there was actually examples of that as well, and even contractors were coming in and giving cost estimating and constructability recommendations. So the participants were worldwide, as Lars mentioned, and we had people and tools, and again, this was not about, you're going to be seeing a lot of tools, but it was more focused on the process. We wanted to eliminate the constraint of saying you must use a certain tool. One thing that we did point out is that you must use open standards and collaborate with Open BIM as much as possible to be able to cross over and to be able to jump into the 3 phases. So the 3 phases again: space planning, concept resolution, and detail design. And the teams could decide, for example, we don't want to do step 1 and 2, we want to go straight to detail design and work on the equipment layout of an operating room. Or they could say we want to go through the entire process and maybe even redesign the layout. So that was the workflow. Some of the results, and we actually had identified specific tasks along the way. We numbered 1.1, 1.2, 1.3, so there's a whole list, a laundry list of about 30 things that the participants could be involved with. And the result of this last few days is that we're actually going to be sending out certificates to teams that did different parts of this. So saying, this is a piece that you did. And we've kind of formalized those workflows and tried to show the inputs and the outputs. So if I'm doing early design, how do I pass that early design requirement to an architectural team to do the more detailed design, and so on. And there was a series of these diagrams. We'll actually be posting these on the web as well. Okay, so this was the basic schedule. From about June or so, we started preparing the material. There was a lot of research and talking and looking at different options for different sites and collecting information. So that happened from then until literally September 21st. On September 22nd, we started, actually even before the 21st, we allowed the teams to come in and start practicing. And then on the 22nd, we submitted the final requirements of the project, and the team started going. So this is just from a few days ago. So each day, it started growing in a collection of teams and experiences and the things that they collaborated with until yesterday, the 23rd, where we had actually quite a bit going on. And I'll go over each of these points in more detail. There's a little tiny graphic here, but I'll be zooming in. So the first phase was the startup phase. So we started, again, what I presented earlier today, we wanted to make this live, so it was on the internet. So a lot of the material was live on the web, in model servers and in online systems and Google Docs and all kinds of things on the web, using Skype, using all the tools that are available on the web, including BIM, to be able to collaborate. So we set up the program requirements. That's what you see in the little round the bubbles there. That's a bubble diagram of functional requirements, assuming that the plan is not done. We're saying, okay, if we strip away the actual final layout and say, what is the requirement of this hospital, that's what it would look like. And that was placed on the web. And then the teams were given access to that, and we started to refine it. So it was on the web. One of the tools is our tools, the Onuma system, Google Earth, going from Onuma system into Google Earth, visualizing the blocking and stacking early on and making sure that how it fits together. And then we even went through as a team, before we submitted it to the public and to other teams, we tried to mimic the entire process. And our solutions weren't complete. We kind of went quite a bit, and we actually even created plans from early diagrams going into Revit, going into ArchiCAD, going to other BIM applications, and then to make sure that the steps made sense. Then when we opened it up to the teams on the 22nd, here's what happened. We had one team. I'm going to go through. Some of these are kind of random, but there's pretty much an order of what happened on that day. MJ Medical out of the United Kingdom came in and they saw that there was an emergency room floor. They were only interested in the emergency room. They didn't care about the rest of the hospital. They were very focused on, we want to plan this emergency room. So they actually stripped away the plan and pulled the rooms out of, we had the shape, basic shape of the building. We said, if you want to follow that shape, that's fine. If not, you could try something different. But they decided to follow the shape and make a proposal of different emergency room equipment. And they actually even created more detailed plans and a full-blown, like a 50-page document of all the pieces of equipment that would go into those rooms. They went to quite a bit of detail. And they actually then bumped into another team that was working on, from a different perspective. It was Gary Technologies out of Los Angeles. And I'll be hitting them later on. But as you're seeing here, the other models we were using Solibri to pull IFC files out to see how the building was looking, ArchiCAD. So it's that random pattern that Lars was showing in the beginning. There was a lot of things going on. They were starting to coalesce and come together. And the IFC model then from the Onuma system was pulled out into other applications, for example, in Solibri to look at. IFC went out to Tekla along with, there was some CAD files, so there was a full-blown Tekla model that was created that was presented yesterday for the first time. I was pretty blown away by the level of detail. They actually went in and did quite a bit of detail from the EDR group using Tekla. Another group, Deborah McPherson out of Washington, D.C., was interested in space standards. So she was looking at omni-class and classification of spaces. I don't believe she did any actual layout of plans. And please correct me, the audience that's online, please realize that we're digesting this even from a few minutes ago. I'm collecting data as coming in online. So it's still, things are happening while I'm presenting here. Whitestone Research is a group out of Santa Barbara that said, okay, we see a model for a hospital coming in. Our specialty is to give reports on life cycle costs of maintaining that type of a building. So they submitted a report and pushed it up to the server so others can access it, of saying, here's the cost of maintaining the equipment in the building for 20 or 30 years, how much it's going to cost to wash the windows, what your taxes are. So they have historical cost data that they start applying to the building. And the most interesting thing about Whitestone is most of their work in the past has been going into existing buildings and giving guidance to the owners of what their facility is going to be about. But here they're actually giving us input while the building is being designed to help us make better decisions about what kind of design we want. So when we say we want a window that has a good thermal rating or has a good view or whatever, that's great, but there's also other implications like, well, how much is it going to cost you to clean that window for 30 years? Do you want that type of window? And then the owner can make a decision on that. So the complexities of working with design, sustainability, engineering, it's absolutely impossible for any single group to solve everything. Therefore, we have to be able to communicate in real time to other groups and make those decisions. So that was Whitestone Research. Tokumo from Washington, D.C. is a cost estimating tool on the web in the cloud, and they are connected. They actually have a connection to Onuma, to our system, through web services. In other words, their tools on the web we're on the web, and they can actually pull quantities as we're making the design and give a cost estimate, an early cost estimate, obviously, but it's a cost estimate nonetheless that you can continue to refine and make decisions on the different implications of the design. Michael Scarmack from Food for Thought took the model and actually started doing visualizations of different types of energy. I think it was energy use and airflows. So data driving graphics, just like what Rolf was showing earlier about how you can visualize different ways. If it's dynamic data and you can push it into the model and say, what does that look like? Let's change it. What does it look like again? And that's what that Google Earth view is about. We use Google Earth a lot because it makes the model accessible to a lot more users, a lot more participants. You're not required to use complex tools. So this is an example of how it was used for that. Balfour Beatty actually, in fact, before I go there, let's go back a little bit. Balfour Beatty actually started doing a more detailed cost estimate. So they came in, took the IFC model. Let's see if I can get the sequence right. They took the IFC model, they're doing analysis in their tools, and they had cost estimating and submitted a more detailed cost estimate. So there's two parallel tracks. We had cost estimating from Balfour Beatty and another one from Tokumo. It's actually okay to have different types of analysis that can be done. And obviously this project with so many teams, a real project would only have 3 or 4 teams, and here we have many teams working at the same time. Okay, so then as we move on to the next day, this was yesterday. Now we're going into, oh no, this was the day before. Now we'll go into yesterday. Yesterday we started seeing more postings from MJ Medical of more detailed layout of equipment, including that long equipment list. We had the Ecotech team from Autodesk actually taking the model and doing different types of energy analysis and showing it to us live. Unfortunately, I don't have an animation to show today of that, but they were spinning around and doing different types of analysis with that. The Tekla model from the EDR team. Here's one of the details of a piece of the building again. This is kind of a connection that they were analyzing, but they had a full-blown model of the Tekla. They presented yesterday morning. We actually didn't get their IFC file into the afternoon. There's an interesting side story about that because this was one group that was not connected to the web live. So when they were presenting, their model was not available on the web. Therefore, others couldn't grab it until the afternoon. So that's kind of a lessons learned that if we have live connections, then you don't have to negotiate and waste a day. So this is kind of something that will go into the next, as we head into Washington, D.C. Gary Technologies. They actually went through some quite detailed studies. They took the model that MJ Medical was using to do analysis and the model that was already complete from the initial prep work that we had done. And they went through a series, and I'm not even sure exactly what I can kind of tell from here, but they haven't posted a lot of details of what exactly this is. So they used the Onuma system. They took IFC out into Gary's text tool. They did a program analysis in their tool, which is kind of similar to the things that other tools are doing, including our tool, but from a different angle again, which is great. So you're seeing color-coded spaces. They're building geometric rule sets with parametric relationships, looking at controls and reference factors, and running iterations of spatial and programmatic requirement compliance. I believe that's what the chart is there, to develop 3 schemes. So this is kind of a rapid analysis. Let's analyze it and look at the 3 schemes. Verifying quantities with IFC, and then analyzing the results. And I believe they went through iterations of this, and they did this pretty quickly. All of a sudden, at the end of the day, we saw these graphics coming in from Gary Technologies, so that was really great to see. Another side note is Gary did actually talk to Balfour Beatty. So this was relationships that were kind of forming as things were happening. Balfour Beatty was watching and saying, okay, we see Gary is doing some work with the model. We want to start giving them guidance on construction and cost estimating for that from a contractor's point of view. So they were giving them that, and their Balfour Beatty's engineering group started looking at mechanical and electrical systems. They have a very long, almost 40 pages of diagrams like that about different systems that could go into the building. So again, that's a BIM from a different perspective. That was last night. So we had the Tekla model, we had the IFC model, we had the ArchiCAD model, we had a Revit model. Last night about 8 o'clock, I was online and I noticed a team that was working in ArchiCAD 13. The new version of ArchiCAD 13 has a live model server, and they were just starting to learn how to use it. And I said, well, why don't you take the IFC model and put it into the ArchiCAD model and put it on the web? And that's exactly what they did. They took the model from the IFC, from the Onuma system. They took the IFC model from Tekla because now it was posted online. They pulled it into ArchiCAD and they started collaborating with people around the world in another kind of a model server sphere. So they were looking at curtain wall systems and they were chatting online through the model. Again, very interesting example. Obviously, it was just a few hours work that they were doing. So it was not a complete solution, but it was the beginnings of what can happen if you want to get a different perspective. And here's the Tekla IFC model that was brought into ArchiCAD. Another group from and this was the Food for Thought team that has actually won several BIMStorm awards. So they're a team that is all over the U.S., very small, 1 or 2 person offices, and some of them are larger, like 50-person offices. And they were collaborating to create new teams. And this goes back to this morning's discussion that you don't have to be a large firm to be able to collaborate and work like this. So this is the Food for Thought team. They actually created a PowerPoint slide and they're describing their process, and that's already on Google Docs. I believe they posted it. And one other team from Food for Thought actually did an energy balance evaluation using Graphisoft's Eco Designer, so doing carbon footprint on those designs, and then also taking it into other applications. The Food for Thought team also on the lower right, they did a lot of chatting through the model in the Onuma system. So they were actually using the model again to channel communication through the model rather than having emails and other files attached. So this is a glimpse. It's not everything that happened. There's a lot more material online, and we're still digesting it. And we're going to have kind of a review again in a week or 2 with the other teams. And I want to thank everybody that's online that did participate. Lars, is there anything else you think I should show? Or are we done time-wise? Yeah. One more point. Actually, right before I came up here, there was an email that came from CSI that said, "We see that you're working on hospitals. We're working on OmniClass for hospitals. Here's the latest OmniClass table." So we're drawing out reaction from the industry of by doing this, by exposing this and being transparent about it.
So the only thing that I could share with Kimani is actually to say thank you to all of the teams that are represented in this webinar. You have done a fantastic job doing this, and now you can rest for a couple of weeks, and then we are on for a 3-month drive up till Washington DC.
That's right. Thank you very much. Okay, so we'll sign off on the GoToMeeting. We're done with that, right? Yes. Okay, we're signing off the GoToMeeting. Thank you, everybody.
We have an avalanche.